Yo, students, welcome to lesson 7.5, Similarity in Right Triangles. It's about to happen. Open up your ears. Here we go. Similar right triangles. What do we know? This is a mouthful, so get ready. If an altitude is drawn, an altitude is drawn from the right angle of a right triangle. All right, and remember, an altitude is when you take a line from the vertex and draw it down to form a 90-degree angle at the base. All right. So if I draw an altitude in a right triangle from the right angle, then the two triangles formed, and these two triangles that are formed is this small guy right here, all right? And then we have this guy over here. See, I got two triangles that are formed. They are similar to the original triangle, which is BAD, the big triangle right here. And all of these triangles, therefore, are also similar. All right, so basically there are three similar triangles. This small guy right here, this guy right here, and the whole big triangle. And if you look below, I broke it down for you, okay? There's three triangles that are formed. You have your original triangle, which is BAD. All right, that's the big one. We got BAD. That's our big triangle, okay? So triangle BAD is our original triangle. Let's get rid of that for a second. Then we have our second biggest triangle, right? And that would be this guy. That would be DAC, right? So DAC. That's our next triangle. And these two triangles are similar to each other, right? This one and the bigger one. And then finally we have our little baby triangle, our little baby triangle, which would be this guy, ABC. And that's our small triangle. All right, and these three triangles that are formed are similar to each other. And with that, we're probably going to use that theorem to solve some problems. So I hope you're ready because it's all about to happen. But let's start with the basics. If you look below, write a similarity statement for the three triangles in the diagram. There are three triangles, the big one, the medium one, and the small one. We're going to write a similarity statement and label the three triangles below. So what are our three triangles, okay? Well, let's start with the big one, okay? We have our first triangle that is, let's see, let's label this properly. Our right angle is K, okay? K goes to L, which is the shorter side. KL is our shorter side, so let's label that properly. We have KL right here, KL, that's the shorter side. And then we have J on the outside. So that's our big triangle, triangle KLJ. All right. Remember, you got to be accurate with which is the small side. You can't just label it all hibbity-dibbity. We have our next triangle, which is the second biggest one. And our right angle is right here, right? So that's our altitude. So we have Z right here. The smaller side would be ZK in this one. So K goes right here. And then we have J over here, right? So we have ZK, J. Oh, I outlined that horribly, but you get what I'm doing. Triangle Z, K, J. Z, K, J. All right. And then finally we have our small little guy right here, right? And our right angle, once again, is at Z. It's right here. So we're going to put Z as our right angle. And this would be our shorter side, ZL. So ZLK. ZLK. Look at that guy. He's so cute. ZLK. I love them. That's our smallest triangle. So triangle ZLK. Okay? So those are our three similar triangles that we can draw within this triangle, and all three of them are similar as we stated right here. All right? This drawing that you're going to do is coming really handy for solving the next two problems. Come, follow me to the next slide. Boom. In JML, we know LM is equal to 3. So LM is right here. We know that's equal to 3. We know LJ, which is right over here, is equal to 9, and we know JK is equal to 12. What is the value of X, which is missing right here? Now looking at this, we're like, whoa, what the hell do we do? But if we break this up into three smaller triangles, I have a feeling we can do this. So let's start. Let's first draw our three triangles and label them, okay? So we got our first smallest triangle, which is J. I mean, this is our biggest triangle. J is our right angle, L is our smallest side, and we have K right here. So we have JLK, right? That's our first one. So triangle JLK is our smallest one. Now we have our next biggest one. The right angle is right here. Remember, that's the altitude, so that's at M. So M is our right angle, and our shortest side is JM. All right, so we're going to label that as our shortest side here. See how that corresponds? And our biggest side, well, let's see, let's draw it out. We have K. So JMK is our other triangle. And then finally, our third triangle would be over here. Once again, our right angle is right here. All right, let's draw that out. Look at that right there. And our right angle is at M. The shortest side is ML, if you're looking at this, and the bigger side is J, so we put that there, and that's our final one. So triangle JLK is similar to JMK, which is similar to MLJ. Those are our three similar triangles. Now we're not done yet. Now we have to label our sides. And then since they're similar, maybe we could do some solving. So let's do some labeling, okay? So JL is 9, JK is 12, and do we know the whole length of JLK? No, we just know this part, so we're going to leave that blank. So we have 9 and 12. JMK, so we know JM is X, all right? We don't know what that is, but we will put an X there, okay? We know MK, well, actually we don't, so we can't put anything there. And then finally, JK is 12. Okay, and then finally we have our third guy right here, our little pipsqueak. We know LM is equal to 3. We know MJ, let's see, is equal to X. And then we know LJ is equal to 9. All right? And using this information, we should be able to set up a ratio, right, to do this. Now, this is the kind of part that takes that art, that finesse of mathematics. You have to be able to set up an equation, right, that would help you out here. And looking at this, I see a few. I don't know if you see any, but I see a few. Does anyone see one? Or am I alone here? No? Yes? All right. I'll give you an example of one ratio that I could set up, right? Looking at this, I see that if I wanted to solve for x, I could say 12 is to 9, right? These hypotenuses of these two smaller triangles, so I'm going to write that. 12 is to 9. This is the big hypotenuse, right, over the small hypotenuse. I don't know why I'm writing it like that. So 12 is to 9 as x is to 3. Right? So I could set that ratio up to solve. Well, now I could solve it, right? So I'm just going to cross multiply. So 12 times 3 is 36. 9 times x would be equal to 9x. To solve for x, I'm just going to divide both sides by 9. And I get x is equal to 4. Big-a-boom! Did it. Good for us. All right? I'm kind of proud of us there. We did it. We did a pretty good job there solving. And, you know, we deserve some credit on that. Were there other ways to solve this problem? Sure. That was just one way to do it. Let's do it another way and see if we get the same answer. I'm kind of interested to see if that works. That was one way. You can keep that on your papers. And if you're interested in seeing another way, go for it. If not, fast forward me. I don't care. Here's another ratio that I think I could set up. I could do 9 is to 3. So 9 is to 3, the legs of these two triangles, as 12 is to x. All right, 9 is to 3 as 12 is to x. Once again, I could just cross multiply now, and I get 9x is equal to 36. Doesn't this look a little bit familiar? Divide by 9 is x equal to 4. So look at that. It doesn't matter which ones you set up as long as you set up the right ones together. Remember, they have to be in the same place. I can't say 9 and 12 because those aren't in the same places there, right? I have to say 9 is to x, or sorry, 9 is to 3 as 12 is to x. They have to be in the same places. All right, let's try one more, a little more difficult this time. In the figure below, CD is equal to 12. So CD is right here, that's 12. And CB is equal to 5. Great. What is the length of AC and AD? All right, let's start with AC before doing AD. Let me zoom out a little. So the first step here is, once again, let's draw our three triangles. That's going to help us out a bundle, okay? So our first big triangle is, well, our right is right here, our big guy right here, right? This is our big boy. That's our big boy. So the right angle is at A, right? The shorter side is AB, so we're going to label it appropriately. Like, this is our shorter side, so it has to be shorter here too. And that's D. All right, that's our big guy. Our second biggest one, well, we got this guy right here, right? So the right angle is at C. All right. The shorter side is AC, so I'm going to put my A here. And my longest side is D, so I'm going to put that over here, ACD. And then finally, I got my small baby triangle. My right angle is here at C. Right? The shorter side is CB, so I'll put that here. So I'll put B here. And finally, the last one is A. So these are my three similar triangles. Triangle ABD is similar to triangle CAD, which is similar to triangle CBA. Well, now let's fill in the information we know. Do we know, well, okay, yeah, do we know, well, oh, hold on. I'm going to say this. Since we're looking for AC, let's put an X there. Okay. So do we know what AB is? No, so we can't fill in anything here. Do we know what AD is? No, so we can't fill anything here. And do we know what BD is? We actually do, right? It's not 5, it's not 12. It's if I added those together, 5 plus 12, so that would be 17. So we can put that there. Our next triangle, all right, our smaller guy right here. Do I know what AC is? Yeah, that's X. That's what we're looking for. Do I know what CD is? Yep, that's 12. And do I know what AD is? Nope, I just have to leave that blank. And finally, my small little guy triangle. Do I know what CB is? Yeah, that's 5. Do I know what CA is? Yep, that's X. And do I know what AB is? No, that's by itself. So we did our labeling. Now it's the easy part. Yay! We just set up our ratios. And I'm looking around here. I'm thinking, what can I set up? And I see these guys, right? My two smaller ones. They got a ratio right there. And what I could say is this. X. Oh, let's put that in blue just to make me feel better. So X is to 5 as 12 is to X. To solve this, what do? Well, I'm going to cross multiply, cross, and I get X squared is equal to 60. Take the square root of both of these to solve. Sorry, I should say this. If you have an X squared, to undo a squared, you take the square root. It's like when we did Pythagorean theorem. And we get X is equal to the square root of 60. Now you could write that as a decimal, but I'm just going to leave it as this, the square root of 60. All right? And that goes right over here, square root 60. Beautiful, we found out what AC is. AC equals square root of 60. Now this is where it gets funky, right? I want to find out what AD is. All right, AD right here. The problem is I can't set up any ratios, right? Because 17 is to this. 17 is to AD, so I guess I could put a Y there. Is to, well, there's no other sides I know. Well, that kind of screws me. But here's what I can do. Now that I found one piece of information, I can solve for AD, right? I could do this in a kind of indirect way. This is a right triangle, right? And I know the two legs. So if I know the two legs of this triangle, I could do the Pythagorean theorem. How cool is that? So the Pythagorean theorem, if you remember, is a squared plus b squared equals c squared. So to find AD, right, which is our hypotenuse, it's important that we know that, that's our C, we would just do the first leg, which is 12, so 12 squared, plus our other leg, which is 60, the square root of 60, squared, equals c squared. And that's what AD is. If you put this in the calculator, you get 144 plus 60 equals c squared. Ooh, follow me over here. I'm going to add, so this is 144 plus 60 equals c squared. I'm going to add these. I get 204 is equal to c squared. Take the square root of both sides, and, well, it's going to be a decimal, so I'm just going to leave it like this. The square root of 204 is equal to c. And that is my answer for AD. So I'm just going to leave you with this parting advice. If you cannot directly solve for this, you could always use the Pythagorean theorem if you know two sides. You can use the Pythagorean theorem if you know two sides. Two of the legs, a leg and a hypotenuse. All right, guys, this is your last lesson before your study guide, so be off, be free. I wish you luck in the world. And remember, never, ever, ever lick a subway pole. Trust me, I was sick for a month.